Hello, I'm Lakshmi Shetty, Assistant Professor, Department of Electronics and Communication, Sri Madhva Institute of Technology and Management. Uh, Today in this video, we will be going ahead and starting with Module 5 of ARM microcontroller subject. The topic or the Module 5 deals with RTOS and IDE for embedded system design. So today's topic we are going to deal, or let's before that we will just go ahead and see what is the syllabus of module 5. The first part of module 5 deals with all the operating system basics like what are the different types of operating systems that we have, what is the operation that the operating system does, scheduling techniques, then communication synchronization issues, racing, deadlock. So most of the terms that we study in the part 1 of the syllabus are related to operating system, and terminologies will be familiar to you, but this we have to customize it for the usage of embedded system. Then the later part of the syllabus of module 5 consists of the IDEs that are used for embedded system design. What is the embedded system development environment, block diagram, what are the different components of IDE, all emulators, debugging techniques, these all will be dealt in the part B of module 5. So today's topic of this video will give you the basics of operating system. The first topic will be operating system basics. Now, when we talk about operating system basics, first thing that we should know is what exactly is operating system. Operating system is, you have already learned an operating system subject, so you all are aware, but just recall. Operating system basically acts as a bridge between what? Bridge between the user application or task and the resources or the hardware that is there in the system. And what are the primary functions that the operating system does? There are various functions that the operating system does, but basically operating system's primary functions is to make the system convenient to use and to organize and manage the system resources. So these are the two basic functions of operating system. Let us see the architecture of operating system. As we said that the operating system acts as a bridge between the application and the hardware. So you will see that the kernel services, or the kernel is a core part of the operating system. Kernel services acts as a bridge between the user application and the hardware, and different kernel services are mentioned in the architecture, and the interface between the kernel and the user application is known as application programming interface, whereas the hardware is connected with the kernel through device driver interface. So this is the basic operating system architecture. So let's move on and see what are the different functions of operating system, or what are the kernel being the core of the operating system. What different services does the kernel handle? This also concept is familiar to you. Just a recall in this video, like what all are the kernel services. First being process management, then memory management, file system management, IO system management, and protection and interrupt handling. These are the various services that are the kernel is responsible for, and one by one we will see in detail what are the different services, starting with process management. Now, process management is the service which the operating system deals with, or to be precise, kernel deals with. This is regarding dealing with the managing of a process or a task. It can be a process or a task. What exactly is a process and what is a task? We will see that in subsequent videos. But process management is an activity which deals with managing the process and task. Now, what kind of activities or what kind of managing does it does? So there is the first, the management, process management includes is setting up a memory space for the process. Now, how much ever the memory is required, the allocation of space to the process is done through process management. Then loading the process code or the process exactly into the memory. So now that the setting of a memory space is done, then also transferring the process code into memory space also comes as a services of kernel under process management system. Not only that, for the execution of the process, there is a requirement of allocation of system resources. There are various system resources that are required for the execution of the process. Now, what all are the system resources that are needed that will be allocated to the process under the process management through kernel? Then even scheduling and managing the execution of the process. Scheduling techniques, we have learned that in the operating system, which process should get the CPU allocation first and later on. So the scheduling is also comes as the kernel service under process management. Then PCB, process control block, setting and managing the process control block also becomes one of the services offered under process management. Then inter-process communication synchronization, if there is any communication related function going on between two or more than two processes, inter-process communication and synchronization. That as well as lastly, the process termination and deletion activity comes under the kernel services of process management. This is all about process management. Basically, process management is setting up the memory allocation, loading the process into the given memory space, allocating system resources, managing the system execution or the process execution and scheduling, and the termination and deletion. These are the services that are offered by kernel under process management. The next comes memory management. Now, memory management, the part of kernel that is responsible for memory management is known as MMU, also known as memory management unit. Memory management unit of the kernel is responsible for the memory management, and what it does, it keeps a track of the memory, whether it may be a primary memory or a secondary memory. So both are under control of the kernel services, and it keeps a track of which part of the memory is currently used by the process, which is free, which is the free space that is available for the next allocation. All this track is kept by the MMU. Then not only that, allocating and allocating, that is giving the memory space to the process. Deallocation, after the process has completed its execution, or in case of preemption, the deallocation of the memory space from the process is also being done by memory management. Then free disk space management, that is in case if there are the free spaces available in different addresses, then if the free space available is a small free space, but the chunk of small free spaces are available in different locations, then relocating those locations and making it as a big allocation, this comes under free disk space management. All this is done by MMU. Then not only that, also when the data backup needs to be taken up, that is the time interval where the disk will be activated for the backup data, is also managed by MMU under the memory management services. Next comes file system management. Now, what exactly is a file? When I say file system management, then we have to see the definition of file. File is nothing but file is a collection of the related information. There are various examples of files that an embedded system can have. Embedded system can have file like a program file, that is a source code file, can be a program file. Then there can be a text file, image file, word documents, or there can be audio or video files. So all these are examples of file systems that are available in an embedded system. So file system management, managing of all these files, comes under the services of file system management. Now, what exactly the kernel is responsible for? The kernel will be responsible for creation, deletion, and any alterations for these files. Not only files, kernels will also be it will also be responsible for creation, deletion, and alteration of various directories. Directories are the one where there are collections of files kept in. So if we have to create, delete, or alter a directory, even that becomes the responsibility of kernel. then saving or transferring the file from a primary storage to the secondary storage, or saving the file in the secondary storage memory is one of the responsibility. Then dynamic allocation of file space, even naming convention, that is giving flexible naming conventions for the file, is certain responsibilities of kernel that comes under file system management. Then comes IO system management. We will not go into much detail about all these functions because in the operating system subject we have already dealt with a lot of in detail explanation about all these functions. Each function was a chapter in your operating system, so you are familiar. So this video is basically just going through the operating system basics, just a recall. Okay, so let's move on to the fourth function of operating system, that is IO system management. Now the IO request that comes from a user, kernel will be responsible to route those IO requests that comes from the users to appropriate IO devices. There are various IO devices that can be attached with the system. Here we are talking specifically about the embedded system. Embedded system can have various IO devices. IO devices examples can be a keyboard, a mouse, or a printer, a scanner. There can be a lot of IO devices that can be attached with a system. So here kernel maintains the list of all the IO system or all the IO devices that are attached with the system, and it keeps the list of it. Now, and this list keeps on getting updated as and when any new devices is installed to the system. The list gets updated. And who takes care of all this IO system management? There is a unit known as device manager. Device manager, that's a part of kernel, is responsible to handle the IO related system calls. Then device manager also goes ahead and has certain responsibilities. What are those responsibilities? The device driver has to device manager has to load and unload device drivers. Then it also does the exchanging of information or control signals to and fro to the devices and the system. So any system call or any control signals that flows through the device to the system is done through device driver or device manager. Sorry, not device driver, device manager manages this exchange of information or the control signals to and fro from the devices. So these all are the activities under IO system management that the kernel does. To be precise, device manager does. The last primary function or the last function of the kernel is related to protection and interrupt handling. Now first we'll see just the small part of protection. Protection means it deals with the implementation of lot of security policies. Nowadays all the operating systems comes with the protection policies or security policies, wherein what this security policies does is these defines the restrictions that a user can have or user can access, what kind of access the user is given, and different application and processes or the users, which all system resources they can access, or that restriction is defined under security policies. So these security policies are inbuilt in most of the operating system, or even the user can define. Now here the next part is related to interrupt handling function. So kernel is provided with the handler mechanism. We have an interrupt handler mechanism which manages both external as well as internal interrupts that are generated by the system. Now there are many add-ons that can be added to the system. What all are the different add-on services or components that are added to system? Examples can be network management related services, network communication related services, or graphics, user interface graphics. Timer services means we can say, a delay generator or a timer. So these are timer services that can be some of the add-on services added into the embedded system. Error handler, database management, these are various add-ons that a system can have in terms of a service or a component, and many OS offers these add-ons. Now whenever these add-on services or components needs to be interfaced with the user application, it is interfaced through the set of standard application programming interfaces, and those are known as APIs. So this is all about the various functions of operating system, and this comes under the topic of operating system basics. Thank you.